All right, let's jump right in. We're talking about two really powerful statistical tools today, correlation and regression. They're all about uncovering those hidden relationships you see in data.
I mean, this is a question we run into all the time, right? Is there a real link between, say, how many hours you spend at the gym and your overall fitness? Or between a company's ad budget and its sales? Well, we're about to find out how to answer these kinds of questions with actual data.
So our first tool is correlation analysis. I like to think of it like watching two dancers. Are they moving together, perfectly in sync, or is it more like when one steps forward, the other steps back? Correlation just tells us if they're dancing together and, in which direction they're going.
And the best part is, this whole story gets boiled down into one single number, the correlation coefficient, which we just call R. It's on a scale from -1 to +1. So a +1, that's perfect sync. As one thing goes up, the other goes up right along with it. A -1 is a perfect opposition, kind of like a seesaw. And if you get a 0, that means they're not dancing together at all.
But what about all the values in between perfect and nothing? Well, here's a handy guide. Anything above a 0.6, whether it's positive or negative, is generally considered a strong relationship. Something down around 0.2, though, that's pretty weak. You can think of this as your cheat sheet for interpreting any R value you come across.
So correlation is fantastic for just spotting that a relationship exists. But what if we want to take the next step? Knowing that ice cream sales and sunny days are related is interesting, but can we predict exactly how many more ice creams a shop will sell if the temperature rises by just 1 degree? For that, we need to level up. We need regression.
And that brings us to regression analysis. If correlation tells us that two things are related, regression gives us the actual recipe. It creates a predictive equation, a formula that literally says, okay, for every 1 unit increase in X, we can expect Y to change by this specific amount. This is how we move from just observing to actually forecasting.
Now, when you build a regression model, one of the most important numbers to look for is R squared. Think of it as a grade for your model's performance. An R squared of, say, 0.5 means your model can explain 50% of the why behind the outcome. It tells you how much of the story your predictors can actually account for.
Okay, that's enough theory. Let's make this real. We're going to see these tools in action with a really fascinating case study. Researchers wanted to understand how student writing is affected by two very modern factors, the AI tools they use and their own learning habits.
The researchers were asking a really specific question. They wanted to know if there's a link between how much students use AI tools, how good they are at managing their own learning, and ultimately, the richness of the vocabulary they use in their assignments.
So first up, they ran a correlation analysis. A matrix like this lets you see every relationship all at once. Now, if you look at where AI usage and lexical richness intersect on this table, you'll see that number, 0.62. Using our cheat sheet, we know that's a strong, positive relationship.
And this shows you exactly how we turn those numbers into a clear, understandable finding. The study discovered that students who use AI tools more often also tend to use a more diverse vocabulary. This is a powerful first insight, but remember, it doesn't tell us about prediction just yet.
To get to prediction, the researchers set up a regression model. The outcome they wanted to predict, the dependent variable, was vocabulary richness. The factors they used to predict it, the independent variables, were AI usage and self-regulation. And because there's more than one predictor, it's what we call a multiple regression.
And the results are fascinating. The beta values here show the predictive power of each factor, even when we account for the influence of the other. The p-values tell us these results are statistically significant, which means they're very unlikely to be due to random chance. And with that higher beta, AI usage seems to be the slightly stronger predictor in this model.
And remember R squared, our model's report card? For this model, it's 0.48. This tells us that using AI usage and self-regulation together can explain a solid 48% of the variation we see in students' vocabulary richness. That's a pretty decent chunk of the story.
Visually, a regression model creates a line of best fit through the data, just like the one you see here. Each dot could represent a student, and that line is the model's best guess. For our study, you can imagine this line sloping upwards, showing that as AI usage goes up, so does the predicted vocabulary richness. It's a powerful way to see the model's prediction in action.
So, we've run the numbers and built a model. But why does this actually matter in the real world? What are the takeaways for the classroom?
The findings offer some really clear implications for educators. Maybe the most important one is that AI tools can be active enhancers of vocabulary, not just something to cheat with. This shifts the whole conversation from should we ban these tools to how do we teach students to use them well,
all while reminding us that self-regulation is still a huge piece of the success puzzle.
So we've seen how correlation and regression can take us from a simple question all the way to a predictive model with real-world meaning. Now that you understand the basics, just think about it. What hidden relationships and powerful insights could you start to uncover with these tools?